Welcome! Today, we're diving into the ultimate modern tech dream, running full desktop-class PC software right from the smartphone in your pocket. For years, we've treated our phones and computers as two totally separate worlds, mobile apps for when you're on the go, and heavy Windows applications for your desk. But if you've been on the internet lately, you've probably seen tons of videos, tutorials, and claims saying that wall has completely fallen. Today, we're unpacking the actual technical reality behind those claims using nothing but facts and technical documentation. So, here is the million-dollar question, and probably the reason you're tuning into this explainer right now. Can a normal, everyday Android smartphone actually run Windows desktop apps and PC games? We've all seen those wild, clickbait headlines where someone claims they magically installed Windows on their phone. Well, let's separate the science fiction from the actual computer science.
Let's cut right to the chase. The short answer? Yes. Some Windows applications and games can absolutely run on your Android device. But, and this is a massive but, it is not a complete native Windows OS installation. The underlying operating system running on your phone is still 100% Android. Your phone's brain hasn't changed, it hasn't suddenly morphed into a desktop computer.
You'll often see people claiming they did a native Windows install, which would mean totally wiping Android and replacing it with Windows. That is just straight up false. What's actually happening is the use of a compatibility environment. This is a highly complex setup that translates applications on the fly, while Android continues running the whole show in the background. Understanding this difference is absolutely crucial before we go any further.
And that brings us to the tool at the very center of all this hype, WinLater. Essentially, WinLater is an Android app and environment. Again, it doesn't convert your phone into a Windows device. Instead, it acts like a host. It creates an environment that combines multiple translation and compatibility technologies so that Windows x86 or x64 software can actually execute on your Android hardware. Think of it like a highly specialized workshop inside your phone, built specifically to read foreign blueprints.
If you look at the WinLater GitHub documentation, you'll see what's actually happening inside that workshop. There's an entire army of translation tools working together. We're talking Wine, Box86, Box64, Mesa, DXVK, VKD3D, and Prut. Now, I know those just sound like random acronyms, but they're basically a dedicated team of real-time language interpreters. When you tap a Windows program on your phone, this whole stack springs into action, rapidly translating different parts of the code so your phone can understand it. Let's break down the most famous player on that team.
That player is Wine. In simple terms, Wine is a compatibility layer. When a Windows app tries to talk to the operating system, something we call Windows API calls, Wine steps in and intercepts them. It then translates those calls into mechanisms that Linux-based systems can understand. And since Android is based on Linux, it actually works. The key takeaway here, Wine is not a virtual machine. It's not an emulator installing a heavy copy of Windows. It's just an incredibly efficient, on-the-fly translator. But translating the API is only half the battle.
Right, so here is where we hit a fundamental hardware mismatch. Almost all modern Android smartphones use ARM architecture. It's incredibly power efficient and totally perfect for mobile. But on the flip side, traditional Windows PCs and their desktop apps have historically been compiled for x86 or x64 architecture. So you have software written for one type of physical brain trying to run on a completely different type of physical brain. They speak entirely different hardware languages. To bridge that massive gap, we use tools like Box86 and Box64. Here's how that plays out. Step 1, the PC application sends out its native x86 or x64 instructions, completely unaware that it's actually sitting on a phone. Step 2, Box86 and Box64 step up and translate those specific architectural instructions into an ARM-friendly language that the phone can process. And finally, Step 3, your phone's ARM environment executes the software. It's literally a mind-blowing relay race of code translation happening in mere milliseconds.
So why is this suddenly possible today when it wasn't 5 years ago? Well, the answer is just sheer brute force hardware power. Smartphones were originally designed for lightweight mobile apps. But today, our phones are basically pocket-sized supercomputers. They have incredibly powerful CPUs, strong GPUs with Vulkan support, massive amounts of RAM, and blazing fast internal storage. Emulation and on-the-fly translation create a huge performance overhead. It's only the raw brute strength of modern Android devices that can actually lift this massive translation burden and still run the app successfully.
Which automatically leads us to the next big question.
Since we have all this incredible hardware power and these amazing translation tools, will every single Windows application work perfectly on your phone? If you load up the latest, heaviest PC game, will it just run flawlessly?
Yeah, the answer to that is a definitive no. Getting an app to run depends on a long checklist of compatibility hurdles. What specific Windows APIs does the app need? Does the phone have compatible GPU driver support? Does it require specific hardware acceleration? And what about DRM or anti-piracy protection systems? Because of all these variables, performance changes dramatically from one phone to the next. If your device is missing just one specific driver, that application simply won't run, no matter how fast your processor is.
In fact, to really grasp the deepest limitation here, we can look straight at Microsoft's own Windows on ARM documentation. It clearly states, emulation is limited to user mode applications. Kernel mode drivers require native support. To put that into plain English, it means basic apps that just interact with the user interface can be translated. But if a Windows program depends on deep system-level drivers, like an intensive anti-cheat system for a multiplayer game or deep hardware diagnostic tools, these compatibility layers just can't fake or translate those kernel mode dependencies. They absolutely require real native support.
So what's the big takeaway from all these technical facts? Running PC apps on your phone is an incredible software translation illusion. It is absolute proof of how advanced our mobile hardware and open-source translation layers have become. But guys, it is entirely an illusion, not an actual operating system replacement. Next time you see a viral video claiming someone installed full Windows on a normal Android phone, you'll know the actual technical reality of what's running in the background.
But this whole technology does force us to think. Despite all the limitations we just covered, it is genuinely mind-blowing that our phones now have the raw processing power to real-time translate and run heavy desktop applications. As these translation layers get better and mobile chips get even faster, the line between a phone app and a computer program is going to blur completely. If our pocket devices can interpret and run this level of complex desktop software on the fly, are we even going to need traditional PCs in the future? I'll leave you to ponder that one. Until next time, keep questioning your tech.